Hello everyone, welcome to Geometry Lesson 5.2, which is all about bisectors and triangles. By the end of this lesson, you should be able to use triangle bisectors to solve problems. Alright, so we have a lot of vocabulary today. I highly recommend that you write this down, maybe make flashcards. If you don't know what these words mean, you're not going to know what the questions are asking you. This vocabulary is super important, okay? So let's start with the word concurrent. Concurrent is when you have three or more lines that intersect at a point. So if I had these three lines, those three lines would be concurrent because they meet at one point. They meet at this single point, and that point is called the point of concurrency. So concurrent when three or more lines intersect at one point, and that point is called point of concurrency. Circumcenter is when you have a triangle and it's the point where three perpendicular bisectors of a triangle meet. Okay, so if we look at this picture over on the right with the perpendicular bisectors, you can see that perpendicular bisectors intersect at the circumcenter. So remember, perpendicular means that it meets at a right angle or a 90 degree. And bisector means that it cuts in half. So if we look, this perpendicular bisector cut that side in half. This other perpendicular bisector cut this side in half. And the third perpendicular bisector cut that third side in half. So that point where they all met is called the circumcenter. And to go along with circumcenters, remember, all of your sides end up getting cut in half. That's important information to know because that's the information you will use in order to solve problems, okay? So if you have circumcenter, that means that you have perpendicular bisectors of the sides of the triangle. And the last important bit of information with the circumcenter is that the circumcenter is the same distance from the circumcenter to each vertice. So PC would be the same distance as PA, which is the same distance as PB. Circumscribed, the circle contains all three vertices of a given triangle. So if we look, there's a picture of a triangle that is drawn inside of a circle, and that just kind of illustrates what I was just saying about how if this was P, this is C, A, and B. All of those lines end up being congruent or equidistant to each other from the circumcenter to each of the vertices. So let's talk about that theorem. The theorem 5.5 is about the concurrency of perpendicular bisectors. Remember, concurrency simply means that we have three or more lines intersecting. Since we're talking about a triangle, we're only going to have three lines, okay? So concurrency of perpendicular bisectors. So where those perpendicular bisectors meet. So kind of what I just said, here's a perpendicular bisector, here's a perpendicular bisector, and here's another perpendicular bisector. And if you have that, then each of the blue lines going from the circumcenter to the vertice are going to be congruent. And you're also going to have those sides that have been cut in half, okay? All super important information. I know I basically just repeated myself on this slide, but you need to know that, and the more I say it, the more likely you are to become annoyed, and therefore remember this information, or just get angry at me. We'll see. You let me know. Then we have more important vocabulary. Okay, so two more words. Inscribed is when the circle's inside the triangle. So inscribed is when we have that circle inside our figure. So the circle that intersects each side of a triangle at exactly one point and has no points outside of the triangle. So inscribed, this circle touches the triangle at exactly one point on each side. And if we draw a line from the center of that circle to that point where the circle touches the triangle, we would get three 90-degree angles. and we would get 3 equal lines. Because if you think about it, those 3 lines are all the same because they're each a radius in a circle, okay? So each of those lines are going to be equal to each other. And that point where they all meet is called the incenter. Okay, so that's called the incenter. The other bit of information that's important about the incenter, so this would be my incenter, is that each of those lines connecting from the incenter to the vertice cuts that angle in half. So angle A, this large angle, was just cut in half. Angle B was cut in half. Angle C was cut in half. Okay, so that's information that you will use. Then, if you're looking for how that connects to what I said on the last example, these purple lines would be the information that we were just talking about, where those lines would end up being equal to each other. Okay, so we have equal angles because they were bisected. Incenter has bisected angles, and then the lines that are perpendicular end up being going from the side of the triangle to the incenter are equal. And this is another way to say that. This is all Theorem 5-6, concurrency of angle bisectors, meaning your incenter. So again, my incenter going from the incenter to the outside of the triangle meets at 90 degrees, and each of those are equal to each other. And then going from the incenter to the vertice of each, going from the incenter to each vertice means that we have angles that are cut in half or bisected. So we have equal angles and we have some equal sides. All right, so if we look at example 1, circumcenters. Point P is the circumcenter of the triangle below. List any segment or segments congruent to those listed below. So if P is my incenter, the drawing's a little bad. That's point P. And I want to know what segments are congruent to segment BR. So remember, circumcenter means that we have a perpendicular bisector and our sides are cut in half. So BR would be equal to AR. If I look at the next one, TC, here's my perpendicular bisector, that would be equal to TB. And my last one, AP, so going from a vertice to the circumcenter, remember, is the same as going from any vertice to the circumcenter. So AP would be the same as BP and CP. So those are really similar to the questions I'll ask you both on your worksheet tonight or today and your test, okay? Now let's look at what some of the questions with incenters would look like. So with incenters, if we know that the measure of angle BAF equals 15 and the measure of angle CBF equals 52, what is the measure of angle ACF? So if we look, remember, incenters have to do with angle bisectors. So BAF is half of my large angle A. So if I draw A, B, C, I would have 15 and another 15, right? That would be 30. And then measure of angle CBF would be 52. So if I double that to get this other part here, I have 104. Excuse me. And I want to know what ACF is. ACF is my halfway, or half of my angle C. So if I find angle C, I can simply cut it in half. So I know that there are 180 degrees in a triangle. So I can do 180 minus 104 minus 30, and I'm left with 46 degrees for angle C. And if I cut that in half, I'm left with 23 degrees for angle ACF. Then, the other part of incenters, the other information we know, is if I have EF, so notice that's going from a side to the incenter, and DF is going from a side to the incenter. They both meet at 90 degrees. What is the distance from F to AB? So going from the side AB to the incenter, we always go on the line that's the perpendicular because that's the shortest possible distance. Okay. Also, with incenters, those are all equal to each other. So I can say EF equals DF equals that third side I want. So EF would be 3y minus 5. I can set that equal to DF, 2y plus 4. And if I solve, I can subtract 2y from both sides, and I'm left with y minus 5 equals 4. Add 5 to both sides, I get y equals 9. And since all of these sides are equal, I can plug it in anywhere I want. So if I did 3 times 9 minus 5, I'd have 27 minus 5, or 22 units. If you have any questions at all on these problems, please be sure to reach out for some help. Like I said, the vocab in this section is of the utmost importance. You really need to make sure you know it, because I will not answer those questions if you come and ask me during your test. I'm unable to tell you because it gives away the information that you would need to solve, okay? So make sure you study. If you have any questions at all, I know I already said that, but I want to make sure you know, please be sure to reach out for some help and have a great day.